This is Unit 5, Day 6. And today we're learning about the imaginary numbers. Example 30. On the axis below, a sketch of y equals x squared is shown. Now consider the parabola whose equation is given the function of f of x equals x squared plus 1. So you guys know that that's a vertical shift, and you're moving it up 1. So this original graph would go up 1, and then it's going to have the same path or pattern after that. So that's y equals x squared plus 1. So it's going to go up 1. That was part A. And part B we already did. What can we say about the x-intercepts? Okay, well, you might look at that and say, now there are no x-intercepts. Okay, meaning this graph that I just shifted here never crosses over. It says algebraically show that these intercepts do not exist in the real number system. Okay, so if I were to solve this, okay, I move this over there and it becomes x squared equals negative 1. Now to get rid of the x squared, I'll take the square root, and x cannot be the square root of negative 1. Your calculators are going to tell you that this is a non-real calculation, so it doesn't exist. Well, today that's going to happen. So if you need to know how to do the square root method, that's here, but I'm going to walk you through it in a minute. Okay, so now it talks about the imaginary numbers here. Okay, so I want you to realize that if you have to know that the word imaginary is also complex. So complex means they're imaginary as well. Okay, so example 31. Simplify each of the following square roots in terms of I. Well, okay, so I have a little saying, and it's poke your eye out. And when you poke your eye out, this negative comes outside. My son's laughing. And it becomes an I. So that becomes I square root of 9. So again, the negative poked out and became an I. So poke your eye out. Okay. The square root of 9 is 3, but we don't write I3. We write 3I. So the square root of negative 9 is 3I. Okay? Again, poke your eye out. So it becomes I square root of 100, which becomes 10I. Okay. Poke your eye out. Square root of 32. So the negative gets brought outside the radical as an I. Alright, so the square root of 32 breaks down to 16 times 2, and the square root of 16 is 4. Now, you don't want to write I4, you write 4I radical 2. Okay, let's try that again. Poke your eye out, but then 18 breaks down to 9 times 2. The square root of 9 is 3, so that gets written as 3I radical 2. So up here, if you're to poke the I out, the square root of 1 is 1, so it becomes I times 1, and I times 1 is just I, and that's where that comes from, okay? Example 32. Solve each of the following incomplete quadratics by the square root method. All right, so square root method is what was just on the bottom of the other page. That means isolate the x squared. So you got to get this by itself. So how do I do that? I minus 8 from both sides. So I'm going to get 5x squared is equal to negative 20. Divide both sides by 5, and I get x squared equals negative 4. To get rid of something squared, you take the square root, but don't forget, if you take the square root of something, you need its positive and its negative result, so then you get plus or minus the square root of negative 4. We just learned that the square root of negative 4 would be a 2i. If you're stuck, it's I radical 4. The square root of 4 is 2. It becomes 2i. So we say our answer is plus or minus 2i. Okay? Part B. Minus 20 from both sides. You're going to get 1/2 x squared equals negative 18. To get rid of something being divided by 2, you multiply by 2, and I'm going to get x squared equals negative 36. square root both sides. X is equal to plus or minus the square root of negative 36. X is equal to plus or minus 6i. Okay, so realize there's two roots. There's positive 6i, there's negative 6i. Those are my two roots. Okay, part C. So I'm going to add 10 to both sides, and I'm going to get 2x squared equals negative 26. Divide both sides by 2. X squared is equal to negative 13. Take the square root, but don't forget when you take the square root, you end up with plus or minus square root of negative 13. The only thing you could do right here is poke your I out. So you're going to get I radical 13. Okay, we're going to come back to example 33 in a minute. But it says without your calculator, simplify each of the powers of I. Okay, so I used to teach the kids a little saying, and it was I to the first power. You have I to the second power, or I squared, I to the third, or I cubed, and I to the fourth. Okay, there's a little saying. I, 1, negatives in the middle. So what you're going to do is you're going to memorize that every single time it has I to the first power, it's I squared is negative 1, I cubed is negative I, and I to the fourth is 1. Okay, so again, here's my I, 1, negatives in the middle. Now, this pattern just repeats itself, but it's going to be in terms of everything's in multiples of 4. So this becomes I, 1, negatives in the middle. So look, your multiples of 4 end up being 1. Okay, look. You add 4 to this, 3 then 4, then the next one would be I to the 11th. They're negative i's. I squared, you add 4 to 2, you get 6. You add 4 to that, you'd be I to the 10th. Those are negative 1s. And then anything with 1, and then you'd add 4, you get 5. You add 4, you get 9. Those are going to result in i's. Okay, so if I go back to example 33, it's really like 5 times I, that's 5i, and then it says product times 6 times I. So 5 times 6 is 30. I times I is I squared. So it's going to become 30 times negative 1. Why is it negative 1? Because I squared is negative 1. So 30 times negative 1 is negative 30, which is choice 3. Example 35. It says, we see then from this pattern that every power of I is either I, negative 1, negative I, or 1. So think I1, negatives in the middle. Without your calculator, simplify each of the following. Okay, so multiples of 4. So what you're going to do is you're going to take the exponent and divide it by 4. So you say, how many times can 4 go into 38? 4 times 9 is 36. You have a remainder of 2. Because the remainder is 2, that means I squared. And I squared is negative 1, so that is negative 1. Okay, again, so 4 goes into 21. 5 times, 4 times 5 is 20. It's a remainder of 1, so it's the same as I to the first, which is I. Okay, how many times can 4 go into 83? 4 goes into 8 twice. 4 times 2 is 8. Bring down the 3, 0. You're going to get remainder 3. And think about that, guys. 4 times 20 is 80. It's the closest thing to 83. So it's the same as I cubed, which is negative I. Last one here. You should notice that 40 is a multiple of 4. And when it's a multiple of 4, it's 1. Or 4 goes into 40. 10 times. 4 times 10 is 40. Whenever it's a remainder of 0, think of anything to the 0 power is 1. Okay, but if it's a multiple of that, you're going to get that. Okay, so the next piece here, it's really 5 times I to the 16th plus 3 times I to the 24th plus whatever I to the 26th is. So you're going to do them all separately, or you could use your calculator if you have it, but watch. So 4 goes into 16, or you think that's a multiple of 4, 4 times remainder of 0. If it's a remainder of 0, it's always 1, so there's a 1. Okay? And you can do the same thing. 4 goes into 23, 5 times. You're going to have a remainder of 3, so it's the same as I cubed, which is negative I. Okay? Last one. 4 goes into 26, 6 times. You're going to get 24, remainder of 2, I squared is negative 1. Okay? 5 times 1 is 5. 3 times negative I is negative 3I. And then you have a minus 1. Combine like terms. And that's going to go to 4 minus 3I, which is choice 2.